Hello, Dr. Chose. I hope all is well and I hope that you and your family are healthy. I'd much rather be doing this presentation in front of you in class. Um, I just hope that life can get back to normal soon. With that being said, welcome to my presentation. What I want people to get out of this presentation is to introduce a new medical innovation and understand how that innovation is going to be helpful in the world of medicine, as well as just with human beings that have diseases. I also want to answer any questions people have about this new technology. What I'm going to be talking about today is a 3D printed heart valve. Yes, that is right. Doctors are now able to 3D print a heart valve for aortic replacements. A transcatheter or aortic replacement valve is the surgical procedure that I'm referring to. Just some common knowledge, this procedure inserts a replacement prosthetic aortic valve into the damaged valve. This valve then takes over and expands and takes over the function of the old diseased valve. Most people or patients with this aortic valve replacement usually have aortic valve disease. As you can see in the photograph that I have there, that is a valve replacement. That is the device that they insert. It's a minimum invasive surgery. So basically, they're going to go in with a wire and place it in your aortic valve, and then it will slowly expand once they release it and pull out the wire. So it's a lot safer than open heart surgery. So that's why a lot of people are doing that instead of the open heart surgery now. So what is the 3D printed valve? The 3D printed valve can be structured however the doctors want or need it to be. All they have to do is scan the patient's heart and then use that scan to print out the patient's heart. So it is more accurate in some cases. This is a lot better than the traditional aortic replacements or implants that were made from animal tissue and metal frames. So instead of using the metal frames and animal tissue, we're transferring over to silicon 3D printed. So that's the material that they use is silicon, and they found that is able to withstand bodily functions and limit leakage from the heart. Why do these 3D printed valves help? Researchers predict that by 2050, 850,000 people will need artificial heart valves. By using these 3D printed valves, surgeons will be able to help more people, and these new valves will also cut the time drastically. I wanted to include a clock because it's a big deal. Usually surgeons take hours upon hours to develop replacement valves, and now all they have to do is scan the patient, like I said, and they're able to print out this valve in an hour and a half, which is a drastic improvement in time and efficiency for the surgery. Testing. Now, with anything, you're going to have lots of testing. So these 3D printed valves are not able to be placed inside of people's hearts at the moment, but doctors and designers are constantly testing the valves to perfect them and be able to use them. They use a finite element method to evaluate stress within the models when opening and closing the valve. Along with that test, they use a pressure testing rig to determine the performance of the valves inside the body. So basically, they're taking the 3D printed valves and conducting a simulation which will allow it to experience what it would inside of the heart. And they're using different materials, mixed materials, just to see which works the best for these 3D printed heart valves and which will withstand the most. Does anyone have any questions so far? I came prepared, so I asked my family if they had any questions about the 3D printed heart valves as I was going along my presentation when I was practicing for them. So some of their questions are, what is the material they are made of? So as I said before, the material they're made of is silicone. They found that that is the most useful material and that it withstands more through the heart and limits leakage. A lot of the problems that result from this type of surgery are leakage, and it can leak into the body of the heart. So with limiting, if we can find a material that limits leakage, because that is a big problem, and that's why the 3D printed heart valves are so effective, because they limit leakage because they're the perfect fit. Challenges. With any innovation, everything faces challenges. The printed models rely heavily on the scan that I was talking about further. This imaging data set, if it does not scan properly or accurately, it can have drastic impacts on the printed model. So a lot of the time, to solve these, by the way, that is just a picture of the scan of a heart. Usually they would use a CT scan. That one I just wanted to give you an app representation of a scan. So overcoming these challenges, it is best to study the scans and make them the best they can be to allow the valves to fit perfectly. Patients can hold their breath and do breathing exercises to help the scans be more accurate. So by doing these exercises while they're being scanned, it allows the doctors or surgeons to limit the amount of error within the scan, so they're able to print out perfectly fitting valves. And there I have a guy holding his breath, just to show that that's the solution to the problem. As I was saying before, these valves are a perfect fit. The 3D printed valves, they're able to be molded specifically to each patient. This is extraordinary and will help doctors do more aortic valve replacements. As I said in the beginning of the presentation, 850,000 people are predicted to need aortic valve replacements in 2050. So if we can get this ready, then we're able to help all 850,000. Like I said before, the CT data are then used to 3D print a physical model of the heart valve, complete with aortic walls and calcium deposits and leaflets. So this is just a drastic improvement in medicine and will completely change aortic valve replacements forever. Are there any last questions? And yes, my family provided those for me too. My dad asked me, can it last in somebody's body? All the simulations they did showed that silicon was the most withstanding material, and that it would be able to conduct proper functions of the heart. So I hope that answers that question. And then he also asked, are they as elastic as a regular heart valve? The silicone material that they are using to 3D print allows it to act as real tissue. So it is almost identical to the actual muscle of the heart. It's obviously not going to be perfect, but it's close to perfect in aspects of an artificial prosthetic valve. This is my Works Cited page. I hope that you got a better understanding for 3D printed valves and how they're going to change the world of medicine, and how 3D printed body parts will change surgery and donors forever. Once they take this transition step, they will be able to apply this to more and more different body parts. Thank you. As I said before, I hope that everything is well, Dr. Chose, and that you stay healthy and have a great summer. Thank you.